Hi, everybody. It's really makes me, it warms my heart to see everybody, all these faces. I miss you guys. So thanks so much for letting me present today. It's really an honor, actually, after all the time I've spent at Cyclotron Road to be back invited to present. So thank you. Um, I'll just get right into it by just starting off with a lot of you know that I've been around, was previously at Cyclotron Road on the staff, and that I developed some of these resources. But I thought it'd be useful to just start with talking a little bit about how my journey through this process of trying to understand how to attach dollar signs to new technologies. So just briefly, I started off doing techno-economic modeling in my graduate program at Cal. I wanted to understand I was really interested in bioenergy and understanding how can we use the Earth's photosynthetic powers to not just mitigate climate change, but to do so in the most cost-effective manner. So that got me starting to look at trying to understand what the true cost of all these new technologies were, and realizing that it wasn't something that was very well addressed in most sort of academic circles. So, that's when I first started doing some of the spreadsheet models that were trying to answer that question. And so my first job out of grad school one of them was joining this biofuel startup called Bioarchitecture Lab that was started by two Japanese co-founders trying to develop a platform for converting seaweed carbohydrates into bioethanol. So that's how I got into seaweed. If any of you guys ever wonder what the hell brought me into learning about seaweed. But at that company, I was responsible for building the cost model for how we could grow, because for fuels, the cost of the feedstock is ultimately the most important thing. So my job was to build the model for how could you grow seaweed at very large scale in the ocean, and what was the ultimate cost of sugar, fermentable sugar. So that's where I really got to work on developing cost models and really trying to test out ways of trying to get to that answer with a lot of sort of incomplete information. And at the same time, we were building this test farm in Chile to try to try to dial in some of the parameters that were governing that cost model. So biofuels did not work out at the time, but actually, and I didn't know this at the time, but the model that I built there would actually be sort of the basis for the RPE program that came out a couple of years ago, and that we're now working under. But in the meantime, I was fortunate enough to meet Alon and started talking about my experience using these cost models, and we mind melded. He had the same kind of experience, realizing how important that was as a tool for an early stage startup in his companies. And so he brought me on to Cyclotron Road to sort of develop curriculum around how to teach early stage tech entrepreneurs how to try to estimate cost with very little information. And that's sort of the biggest barrier. It's that I think most of us are trained to be very accurate, and the idea of sort of using hand wavy methods is sort of antithesis to the way we like to work. But I think the more I learn, the more I just think it's super important to do it even with very little information. So I'll finish this up by sort of talking about how we've used it at Trophic, because I feel like this is finally where I get to actually put my money where my mouth is. So I'll talk a little bit about that. So now I'll dive into it, and please feel free to ask questions as we go along. We don't need to wait till the end. So this is the basic framework that I like to start off with. Basically, in order to be successful as a business, eventually, the value of the product you're making has to be greater than the cost. That's a minimum condition, not sufficient. But what I'm going to talk about today is how to quantify both sides of that inequality as you go along. And it's an iterative process, but I'm just going to talk about some basic ways of thinking about how you can put numbers on both sides of these as you move forward and continuously discover new information. So, so hopefully this, you guys, I don't need to remind you about why this is important, but I think again, a lot of us are more comfortable doing work in the lab, sort of to work on things, as opposed to sort of zooming up to 30,000 feet and testing different scenarios with a spreadsheet model. But oftentimes that will lead to non-obvious insights that make you realize that you should be spending time on something else that's a more valuable use of your time. Also, there's path dependence in some of what we do, and you often won't get a chance to spend other people's money, is the way I like to think about it. You might get a chance to spend other people's money on something new or some new idea, but you're likely not going to get too many chances to pivot. So the earlier you pivot, the better. And doing some really crude modeling, cost modeling at an early stage can often help give you the data you need to refocus. And then finally, it's about optimizing where you put your time. Maybe you should be spending your time building value instead of reducing cost. Both of those, again, are drivers of what's in the middle, which is the chunk that you can skim off the top to actually make it be a profitable business. Okay, so now I'm going to go into what is, I'm not trying to insult your intelligence with the next slide. It's actually a framework that I come back to all the time. Okay, and this is a simple model of a business, and you basically have two factors of costs, right? Your assets, or your capital cost or CapEx, and your inputs or your OpEx. And then you have revenue, which is basically the products that you're selling times the price. And there's sort of two existential questions, I think, in viability of a startup or any business, really. And the first one is ignoring the infrastructure required to manufacture your product. Is the cost of just the inputs lower than the price that you can sell it for? That is sort of the first back of the envelope calculation that that you should be working on for getting it, infrastructure. And this is something I've actually learned as I've gone forward. I used to teach people to estimate costs by combining, doing like essentially what's a levelized cost of electricity in power by combining the capital cost with the OpEx. But I've sort of realized now that especially investors look at this very differently too. It's the separating the cost of the assets from the basic cost of the inputs and comparing that to what the price is. So that's the first existential question. The second existential question is whether the investment in the infrastructure to produce that product earns a sufficient return. And that depends on whether how you're being financed with venture, with equity, with debt. That's something for Robert to answer your questions on. But this both of these link up to, and I'll show examples later of sort of, you want sort of two different models or two different sets of calculations. One is the first, and the second one is this return on investment calculation that investors are constantly doing in their heads, and comparing your business with alternative businesses which they can invest in to earn a return on their money. So first, I'll start with the value side and talk about just ways of thinking about, okay, so you're selling a product. What is that product worth to your customer, right? And most of us are B2B companies. So that means our customer is also a business, and they have that same model of the business as well. But the next slide is going to be talking about how you can use that model to estimate the value of your product to them. But one of the things I noticed in a lot of our businesses is that this is the value chain. And ultimately, all of these products are ending up in something that's being consumed by a consumer, right? And the consumer is ultimately determining the value those products, which then sort of flows backwards to what people are willing to pay. But often the value of what your product is actually being determined not by your customer, but by their customers, right? Or by the product that they're using your technology to produce. So I think this is a useful diagram, because what you want to do is you want to locate sort of the center of gravity of where the ultimate value is, and focus on that link in the value chain, because it might not be your direct the customer that you're selling to. And so once you sort of figured out who's that customer that's getting the ultimate value. So for example, for us, we're selling a protein, and right now we're a B2B business. We're selling a protein concentrate to plant-based meat manufacturers, right? But we believe that there's a label value to their customers, the consumers buying food products, of having a sustainable, high quality protein on the label. That's something that we need to prove out. But that's an example of like, there's a value to them of having functional properties of what we're making in their product, which is very different than the sort of the more intangible value to the consumer purchasing what they think is a healthier food product, right? So once you sort of identified, okay, here's the customer that I'm trying to sell to, this is the framework I use for saying, okay, well, let's try to quantify what's the value to them of our product, right? And I think there's basically 4 ways that you can provide the value proposition to your customer. There's 4 categories, okay? And so it's really helpful to identify at least one where your product is adding value. So the first 2, the 2 on the left, are cost reduction, right? So the first one is just a straight OpEx reduction. Either you're saving them labor, you're saving them energy, or materials costs. The second one is you're providing them with a way to lower their CapEx, their capital cost. And those are both cost reduction value propositions. The third one here, increasing productivity, is basically allowing them to squeeze more product out of the infrastructure that they have, which is essentially a revenue increasing technology. And then finally, just allowing them to make a better product by having higher quality, or allowing them to increase their profit margin by increasing sales by having a better product. So just a couple things to note about this. In general, everybody wants to reduce OpEx. Like, that's the easiest sell, because it's, especially if you have like a drop-in material that's cheaper with the same performance, that is, I think, sort of, that's why you hear people saying drop in a lot. CapEx is generally harder, because they generally are looking at, they already have they've already invested in CapEx. The other thing to note here is that if the industry that you're selling into is not operating at full capacity, or like the bottleneck to their production is often the highest CapEx thing. So it's better if you have an industry that's growing quickly, like this will be a good sell. But if it's like a sort of a legacy industry or something like that, this is probably not a great value proposition to lowering CapEx. The third one, increasing productivity. Again, like if industries that are operating at capacity, which are generally like growing industries, will be interested in increasing productivity to maximize output. But again, if an industry is not growing or operating capacity, they're generally more interested in lowering cost. And then finally, making a better product is a different thing that you need to then talk to. So these are separated. The blue ones, if you want to, when you're doing your customer discovery, you want to be talking to people in engineering and operations who understand what the cost structure of their manufacturing process is, or just their business. This doesn't have to be a manufacturing process, by the way. This can represent any kind of a service business as well. But then to understand the better product, that's generally their sales and marketing people that will understand whether that's a value proposition to their customers. Okay. So I'll just say that in some, if you're selling into, for example, like if you're making like a membrane that's going into some chemicals production process, you might need to make a cost model of their production process to understand how your membrane or component actually fits into their process. And I'll talk about that a little bit later. Okay, so now I'll talk about estimating cost. So when I first met Alon, we kept going back and forth about what kind of model. We were really focused on teaching people how to model cost. And really, what it became very apparent is that, and this is sort of focused, the next couple slides are focused on energy technologies, is that there's sort of two general categories of technologies, widget technologies and process technologies. And Alon was from sort of the widget world, which I classify as sort of batteries, solar panels, and electrochemical devices are good examples of, things that are just solid and put together by components. And the main type of cost model for those types of technologies is really just a bill of materials. A bill of materials is one thing, right? That's sort of the basic part, but then that's just a cost, right? But then there's the value side of it. To estimate the value of the widget technologies, you want a design versus performance model, which, for example, batteries is a model that connects the performance parameters of the battery to the quantity and characteristics of the materials it's being made out of. I was more familiar, my background is more, and Tom Boussy's, this is, his bread and butter is like more process technologies, chemicals, fuels, power production from combustion, where the CapEx really dominates the commercial viability, and your cost model is really going to focus on the cost of production. So it's gonna, be, your cost is gonna be pegged to things like equipment, gas, utilities, and energy consumption, and where the cost of basically all the plumbing and heat and power is a significant factor. Okay, so one of the big realizations that I've had, I started off doing a lot of bottom-up cost of production models, right? Where like I'd say, okay, let's list all the process steps and the equipment, size the equipment, and estimate what the like installation factor is for installed CapEx for this equipment. But what I've realized is that the early stage top-down models based on analogies are often much easier and actually sort of more accurate at the early stage. And so I'll talk about that a little bit and how we've used that as well. So here's an example of CapEx by analogy, right? So there's huge economies of scale in fuels and chemicals production. So one of sort of the back of the envelope tricks you can use is to try to find data from existing commercial facilities on the capital investment cost, and then use what's called a scale factor to estimate what the cost of a facility of a similar type of facility would be based on the relationship between the capital investment cost and the size of the facility using its capacity, its output in terms of tons per year or gallons per year, whatever that is. And this is sort of the equation that, is often used not just to scale equipment like in chemical engineering. But this I found is super helpful to just do really back of the envelope estimates for what the capital cost will be based on the size of your like first commercial facility, which is something I found investors are pretty interested in. One thing I think is just useful to know is that people in industry tend to use this terminology that, like, for example, when I was working at the bioethanol company, it was people would talk about the cost of a bioethanol plant in terms of dollars a pound, which is confusing because you want to think that that's the cost of production, but it's actually when they're talking about the investment cost, it's actually the dollars per pound, per million gallons per year. It's actually a cost per output capacity, and often the per year is just eliminated, which is confusing. So I just to note that it's something that I was like, oh wait, they're saying it's like that chemical plant is like $3 a pound, but it's actually the investment costs in the capex that they're talking about. So just a little note there. I'll just pause here for questions if there are any, because I'm going pretty quickly through this stuff.
I haven't had any come in, Beth.
Okay, great.
Pretty good, but I think that's a good reminder. Please start posting and I'll bring them in.
Okay. Okay. So now I'll just jump into modeling a little bit. This is sort of the progress of a typical modeling effort over time in a typical company, right? And so again, I can't emphasize how important it is to just do the sort of uncomfortable back of the envelope estimates at the very beginning. I'd say right now, and then as you move forward, developing a more detailed sort of bottom-up techno-economic model would become more and more important. But I think one of the problems is false precision. If you have a super detailed model at the beginning, it's not bad, but it can often sort of cloud over some of the simpler relationships that can be expressed in just a very basic one-page model. So I say, like, where we are right now is like we're kind of in between the first two stages. I have a sketch out of a sort of cost of production model, because we're sort of a process technology business, but I still go back to the really super simple estimates we have that are essentially back of the envelope to still think through how we're going to move forward and where we're going to spend our time. And I'll just say that Chris Burke is somebody who's helped develop, and I'll talk a little bit about some of the models he's built, but I know he's now involved sort of on a regular basis with Activate. So I encourage all of you guys to talk to him if you haven't already about your technology and what type of model, especially if you're doing process technologies, how he can help get you to start building a really helpful cost of production model.
So Beth, we've had 2 quick questions come in.
Okay.
Tom, let's start with you.
Yeah, just a quick question about the production costs you're mentioning. Is that basically just the OpEx plus like the CapEx, amortized over the life of the plant? Is that essentially what you're plotting?
In this slide right here, or in the previous one?
Sorry, the previous one, yeah.
Yeah, no, this is actually just the capital cost. So the installed CapEx, this is not unit cost.
Okay.
Yeah. But it's confusing, and maybe I made it more confusing by the way people talk about it, and as a per pound cost or a per gallon cost is often confusing, because it seems like they're talking about that combined like cost of production, unit cost, when in fact it's just a capital investment cost that's normalized to the capacity of the factory.
Got it. Thanks.
Okay.
And Jay, how about your question?
So you kind of alluded to, especially in the case of Trophic, you kind of went after some label benefits for your customers. And I'm just kind of curious how you might quantify that early on when you're doing like a back of the envelope calculation. Or is that something you really have to go out and talk to the customer and kind of just like really get them to commit to a hard number?
Yeah, well, I don't think we're going to get anybody to commit, right? And we haven't, like, I haven't spent a lot of time yet, like, actually trying to quantify that. But I think, you know, as we're asked to sort of validate these sort of claims, and like probably what I should do is go out and just look at by analogy, right? What, you know, I'll go out, like, go to a Whole Foods and see what is the premium that this product is commanding because it has a, you know, ultra eco-friendly or premium ingredient. And so, you know, I think, again, sort of one of my biggest lessons is that there's a lot of data already out there that you can sort of scrape to come up with a pretty good data set to estimate. And not only that, it's more credible. Like when you're talking to people and trying to convince them that you have a value proposition, or like this is your cost structure, they're so much more likely to believe it when you're just benchmarking it to data that's already been demonstrated. And so, yeah, I mean, I think there's really good reasons for trying to just use analogies to estimate your cost and value. One of them is just, it's good for grounding your numbers in reality, but also it adds a pretty good veneer of credibility to people who don't necessarily, they don't want to dig through your cost model or don't have the skills to do that, to understand whether you're trying to mislead them. So if you use real numbers that they can go reference themselves, it's super helpful.
So Beth, we have a number of good questions, but I want to make sure we can also pull in Cody. So perhaps quickly finish up your slides. We can hear from Cody a bit, and then both of you can address some of the questions that have come in.
Okay. Yeah. All right. I'm happy to also just turn it over to Cody for a while, especially since we're talking about CapEx, which is really important in what he's doing in cost of production. Yeah, I'll just, Cody, like, please chip in, because I'm sure you've got a couple really great points to make here.
I have nothing more to add from what you've said to these questions, but I'm happy to chip in moving forward, and I'm happy to pass it off to me whenever you want or not.
Okay. Well, I think I've got about like five more minutes here, and then I'd love to hear your experience.
Yeah, please take all the time you need, and I'll fill in whatever's left.
Cool. Okay. All right. This is sort of what I laid out as sort of like a modeling spectrum of the types of models that you might make depending on what your technology and product is. And you might need to make more than one. So for example, for what we're doing, we just really need a production cost model. Because we need to know the cost of what we're making. But if you're making like a component that's going to go into someone else's technology, you're going to need to model how your component performs, so that you can understand the performance advantage that you have in that application. So some examples down here, again, sort of taken from energy industries, is, batteries and widgets fall into here. Again, this is a design performance model. Like, you need to understand how your materials choices and your bill of materials affects the performance specifications of the product you're making. But then on the far right, again, I mentioned earlier, you might actually need to have a basic model of how your customer is, whether it's like in Alon's situation, when he was working at CO, the battery company, they had to have a model of electric buses to understand how their battery was going to actually improve the performance of those buses. So they had to have a design performance model to understand how to build their battery and how it would affect, the performance patterns of the battery. But then they also had to have a model of like what a bus fleet was doing, to understand whether a commercial or like a municipal bus operation would want to purchase the battery in their fleet. So another great example of this is via separations. Shreya Dave, who is sort of part of this community, even though they're not Activate Fellows, but she has a great paper in Joule on how they used techno-economic modeling to understand the value of their graphene oxide membranes in different applications. And so for those of you who don't know, the work I did at Cyclotron Road to build these resources, like 5-minute whiteboard videos, and the Excel models that Chris Burke built, which are really great, which are free to download, are on this website. So if any of you guys are looking to download, like, he's got a process cost of production techno-economic model for chemicals and also for for fermentation. So those are great, if for nothing else, just to look to see how like a really like fully developed one is built out. And then, okay, now I'll finish up just talking about showing how in a recent conversation with an investor who is interested in digging into some of our economics, the slides that we presented to him, he said we did a really great job. So we don't have a term sheet from him yet, but I think it's always helpful to see real examples. So this is happy to show you what we've actually presented recently. So and this goes to those two existential questions, right? So the first one is just, is the OpEx lower than the price we want to sell it for? And the second existential question is, would be the return on the capital investment in a commercial production facility? So first, before we got into that, it's always helpful just to show a process flow diagram of what you're making and how, and just the basic process steps in that. This was also just, there was an overlay here of just showing what we demonstrated at bench scale and what we still need to prove out at pilot. And then here's sort of our unit economics. So this is basically the model that I go back to. It's like not even, like I don't even do it in Excel. Like I just do it on the PowerPoint slide, right? So it's like, what's the cost of raw material? What's the yield of that raw material from our process? What's the processing cost per kilogram of product, right? And those two things together are basically, and again, the process cost I'm using by analogy. Like I could build it up, by estimating, the cost of chemicals, the cost of power, the cost of labor, but I'm just using top-down estimates here based on what I've known for other similar industries. And then those things together is the cost, COGS, or cost of goods sold, right? And then there we have the next thing is what the price we're going to sell it for. So actually here, you can see the protein product price is actually pretty close to the cost of goods sold, right? So that's a pretty thin margin, but then here I'm adding in what our co-product revenue is as well. So one of the big realizations we had is that even though just by doing this, working on this basic level, we realized that because this other species, even though it's lower in protein, the co-product value is pretty high. So it improves our revenue. Generally, you'd want to go with the higher protein seaweeds, but this is actually one of the reasons why. It's also a lower, much cheaper raw material. So, but this is it, really. I mean, we keep going back to this and the numbers keep changing and we keep revising it, but this has been super helpful for me to figure out what we should be focusing on. This is our CapEx by analogy slide. This is super basic. There's a couple things going on here. One is we're showing how we're, rather than doing our own pilot plant, we're just gonna use co-manufacturing, which are basically contract manufacturing. So that's influenced our R&D. We're only using processes that can be used by contract manufacturing. Nothing fancy, right? And then we'd have our own commercial facility. And what I did here to estimate what the cost of that first commercial facility would be is down here, I'm benchmarking it to numbers that I just pulled off the internet. the Roquette here is a very large pea protein manufacturing facility. I was scratching my head for a long time of how I was going to figure out what that facility cost. I was like, what is a large scale, soy or pea protein? And I tried to figure out all these ways to go into academic papers, but then I just Googled it. Like, I was like, cost of pea protein production plant. And it was a press release by this company where they were advertising how many jobs they were creating, right? So it was actually this impossible number I pulled out from a blog written by an investor who was talking through his estimate for what the cost. So anyway, but that's all I need is 2 data points to draw a line, and that's what we used, and that was sufficient. And then those numbers got plugged in here to this the second existential question, which is, this is super simple. It's almost like embarrassingly simple to me, how basic this is, but it was, this is at the level where we're at right now. Up here, just again, what's the cost of the raw material? What's the processing cost? Here's the revenue we get based on the yield of those products, those 3 products. And then here's the CapEx, again, at $10,000 per ton per year product. So what I was showing from the previous slide is that that's actually a conservative estimate. So this shows we get a payback time. I'm not using IRR, or internal rate of return, which is sort of the next level of what you'd use to evaluate the return. But this is probably very optimistic. But for now, it's what we need to just say, like, yeah, all right, this can work. There's nothing in here that is totally unreasonable, right? So that's my last slide. Happy to turn it over to Cody to hear about your experience doing techno-economic modeling, and then any more questions after that, happy to answer.
Yeah, I'm happy to take over, but if there's any questions specifically for Beth, that was awesome, Beth. I actually missed it last year because I think I was like less than a week away from defending my PhD. So so this is super awesome to see. It was awesome.
Beth, do you mind unsharing your screen? And while you do that, Tom Busi, I feel like we started to touch on your question in the previous few slides, but I'm hoping to get Beth and Cody's read.
Yeah, and Beth, you touched on this. I've done a lot of this myself, of course, over the years for different processes and with different teams. And one of the biggest challenges is data. Like, you use this example of Googling, pea protein, and you got lucky and there was a Roquette, but that's not always the case, right? So how do you hack a lot of these numbers without paying, tens of thousands of dollars for, some industry data that may or may not be any more accurate than what you could put together yourself. So, and this is it's not capital, but it's also raw material costs, utility pricing, capital equipment for analogous processes, et cetera, et cetera. So any general or specific advice around where to scrape data?
Yeah, I'd say people are really good resources. People like you, people have been in the industry. They generally won't know the number or tell you the number, but so you say, well, you have to sort of prompt them with a number and say, is that high or is that low? And then try to do that. I think that's usually, people who've been in the industry, they don't have the exact number, but they have a good sense for, or even just relative values, like which is a bigger factor in the cost, right? Or I think you can get a lot by just sort of, high-lowing it with people.
Cody, I see you shaking your head. Have you used the same approach? Anything different?
Yeah, I definitely same approach. I've had a lot of experience with trying to make stuff up, basically. For example, and maybe I'll just share I got some figures that I think would be helpful. So I spent a long time trying to estimate how much an electrolyzer that cogenerated hydrogen and sulfuric acid costs. And that electrolyzer doesn't exist. And it's presumably very different from a water electrolysis electrolyzer. And I'm also not a electrochemical engineer, right? So basically, I think this problem is pretty common. You want to make something that hasn't really existed before. You don't have the skills to design it yourself. How do you go about estimating it? It's kind of, and what I was taught with techno-economics is that first you have to admit to yourself and the world that you're always going to be wrong, and you're always going to be wrong in one direction, which is you're going to be underestimating how much it costs. And then going from there, you kind of go out in the world and say, okay, what is the most similar thing? So like examples like, okay, I want to make a electrolyzer that co-generates hydrogen and sulfuric acid. Well, there are electrolyzers out there that co-generate hydrogen and chlorine gas, and chlorine gas is also a corrosive material that is, and similar materials are compatible with chlorine gas and sulfuric acid. So why don't I go and look up how much it costs to make to build a plant that co-generates hydrogen and chlorine gas. And then I know that sulfuric acid is somewhat different from chlorine gas, so I'll also look up the cost of a plant that just makes sulfuric acid thermochemically, and I'll throw some of that in there too. And it's really just how can I be as conservative as possible is kind of how I learned about things, because even being as conservative as possible, you're still probably going to be wrong. And just think like, well, what are similar processes? And since they're not the same, how can I, turn the cost down, basically.
Well, Cody, on that topic, actually, Kyle had a question on how similar it needs to be. Kyle, do you feel like Cody answered your question? Do you have something to add or a follow-up?
No, I think that's sort of close enough. I think on the chemicals, like say on like the input side, I think that seems like logical and sort of potentially easy to do. I guess I'm less sure about like on the CapEx side, given like the type of equipment we might use doesn't exist. And so I don't really know, like in that case, like what sort of equipment would be close enough to sort of use as like what is our CapEx going to cost as opposed to the inputs like different chemicals and things.
So I'll just jump in with one rule of thumb that I found is helpful in chemical processing or process industries is the Lang factor, which is basically the installed capital cost. The total final installed capital cost of a plant is about 3 to 5x the cost of the equipment. That's just a rule of thumb that I've seen used, which is, good back of the envelope, if you can figure out the cost of the equipment.
If I can jump in, if you look at the total cost of production, the contribution of depreciation, because it's amortized over 20 years or something, ends up being very small. And you can be 2x off in your CapEx, and it's not going to make any difference in your cost of production, your unit cost of production estimate. So I think people spend way too much time trying to get an accurate CapEx number if they're trying to just see if their total cost of production is in the ballpark competitive. You can be wildly off, and it's all about OpEx. CapEx is not that important.
Just a quick then follow-up question on that. What percentage of your total cost would you say that the depreciation we have to expect to be before we care? So for example, in our current analysis, it could be like 20 or 30%. So 2x does change the price somewhat. So like where would you actually start to care, and where would you say just costs aside?
Again, that depends on scale. It's far more important at small scale than it is at commoditized scale, right? I don't know, Cody, you've done this. What, do you agree with my analysis, or do you say
I kind of want to push back a little bit. And I would, take my opinion with a grain of salt, because I've never made any money for anybody, unlike Tom, who's made plenty of money for people. And I think it depends on the space. I think, for my space, which is typically commodity chemicals, have very low margins in general. And especially if you're getting electrochemistry in the game, CapEx tends to be really, really important. But it really depends on, for thermochemical processes, CapEx is much less important. I think it can depend quite a bit. And I found that CapEx in my process is fairly important. I actually can't see who's speaking. We could kind of talk about what are you trying to build, and what are you struggling with on CapEx? Like what's the machine?
I guess like in the effort of time, maybe like offline. I don't know if this is better for offline. Yeah. I can follow up.
Yeah, definitely do that.
Yeah, Cody, do you have any main lessons that you want to share from your deck here?
Yeah, I've used techno-economics a little bit in definitely all the ways that Beth presented, and then a little bit to also help me understand my process and optimize it, and also throw versions of my process away. I did that a lot. So first of all, one thing that I just wanted to like quickly mention, I've talked to a bunch of investors now, and they've all said a different words for this. There's no good way to put technology and economics together, apparently. So techonomics is definitely the best one I've heard, which I think Beth coined, but there's also, as she's also said, techno-economics, techno-economic analysis, and TEA. So if anyone throws that any of those terms at you, they're also, you know, they're all talking about the same thing. So just something to be aware of. Just to get everyone up to speed, so I'm working on a cement process at Brimstone Energy where we're trying to make cement. So that's kind of what we're modeling. We've gone through many different iterations of our process, and basically we've tried to use techno-economics to understand whether or not how our current thinking is good or bad. And, you know, in full disclosure, for the most part, you know, most of the things we come up with don't make much economic sense. And we have to, you know, in our view, and the sort of way we've thought about it is we kind of have to then, you know, change things considerably, you know, and the techno-economics can be a really powerful tool in allowing you to kind of, how it was described to me is drowning your favorite puppies, right? So you have to, you have this really great idea and it looks so great, and then you do the economic analysis and you say, wow, I could make cement for 10 times the price it is today. This is actually a horrible idea, even though it's emissions free. Let's start over. So one of the best things that I think you can do with a techno-economic analysis is a sensitivity analysis. So this is a version of a graph that we came up with, an early version of our process. And we found basically, so just to orient you here a little bit. So the Z-axis is the dollars per ton of ordinary Portland cement. So like that's like the production cost of ordinary Portland cement today. It's what we're trying to sell. And then on this axis is a tons of supplemental cementitious material sold per tons of ordinary Portland cement, and dollars per kilowatt hour. Basically, these are just parameters of how we could tweak our process. And in this version of our process, we found that if electricity was 3 cents a kilowatt hour and we sold 3 tons of supplemental cementitious material for every ton of ordinary Portland cement, then we could make cement for the same price that it is today. It turns out that in the real world, electricity costs 6 to 7 cents a kilowatt hour, and you can only sell about half a ton of supplemental cementitious material per ton of ordinary Portland cement, which basically led us to the conclusion that this was not a very good way to make ordinary Portland cement. And things had to significantly change. And one thing that was drilled into me with techno-economics is like, the thing that can't change is, well, I'm just going to Google and get a better price of, you know, my plant or something like that. That's probably not a good way to go about things. You know, in general, what we found to be most useful, and also has gained us a lot of trust with the investors that we've talked with, is we try to, you know, let's say we're adding a electrolyzer and we want to do some water electrolysis or something. You know, you can Google 1,000 different numbers for how much the CapEx on water electrolysis costs, but go for it. If you take a more conservative number, then you're probably more likely to be, certainly in the early stages of production, more likely to be accurate. And also, it's much better when the investor corrects you and say, actually, we think the price is lower, than when an investor corrects you and says, actually, this is like you're using way too low of a price. You know, like that's kind of not a conversation you want to get into. And I've been there with a couple investors where they say like, "Ooh, this is a really low price of electricity," or "This is a really high price of hydrogen," or whatever, and it's not very fun. So anyway, when you come into a situation like this, when you say, okay, well, this version of the technology clearly doesn't work, you kind of have options. You can redesign the process, or you can try to cut away some of the process, or try to see what co-products you can make, or that sort of thing. So one thing that we try to do is we tried to, in this case, tried to make some co-products. So we added, there's a version of our process where we could also make hydrogen in addition to supplemental cementitious material and cement. And we realized that if we did that, the economics actually got even worse. So we still had to sell 3 tons of supplemental cementitious material, and the price of electricity had to be 2 cents instead of 3 cents a kilowatt hour in order to make this technology work, which again was very far off of what we found to be reality. And also we had to sell our hydrogen at $2 a kilogram in order to make this version of the process work, which again ended up, for those specific commodities, we found that those were not conservative estimates. Basically, we were being way too liberal with our estimation, which was great. Basically, that's like the ideal outcome. It's like the techno-economics says, like, don't waste your time on this version of the process. Go rethink the process. And it's always possible to rethink the process. No matter how much you think it's not possible to rethink the process, it's always possible to rethink the process. So we then looked at, with this same version of the process with co-generating hydrogen and cement, we looked at, maybe we can tune the operating parameters on our electrolyzer. And we found that that got us to, tuning the operating parameters actually got us to better or more realistic numbers. So we could get into this range of almost 6 cents a kilowatt hour, which is very close to what electricity is today. But we still had to sell our hydrogen for $2 a kilogram, which is, for the markets that we were looking at, about double what the price actually was. So again, this told us, okay, so this version of the process is probably not going to work. And we kind of did this analysis for like, okay, well, if we have to sell our hydrogen for this price and the electricity can be this price, where in the world could this work? And like, okay, it looks like we might be able to do some of this process in California and Germany and in Alberta. But if the goal of our company is to eliminate CO2 emissions by 5% or something like that, having a small footprint in Alberta, Germany, and California is probably not going to get us there. So again, this is just using sensitivity analysis to try to understand how you can change your process. Anyway, long story short is the real value of techno-economic analysis for me has been telling me what not to do. And we can then break down the problems. Okay, so here's one of the big problems with the process as we had showed it. So here is CapEx for a cement plant. And the normal CapEx for a cement plant is this much, and our cement plant CapEx is going to be this much. So we could say, okay, well, there's a big problem with CapEx. How do we, what are the contributions to CapEx, and how do we change that? How do we change the process so we have different components, so the CapEx is different or something like that? So it really just kind of allows you, and I'll kind of not show the rest because I think we're kind of running out of time, but techno-economic analysis can really break it down and say, what are the major contributors to cost? How can you think about, where are the problems in your process if your process isn't going to work economically? And knowing that, how much do you need to start over? Do you need to go back and really redraw your process, or can you just tweak it a little bit, or figure something out? And Kyle or anyone else, I'm very happy to talk to anyone offline if they're going through sort of a iterative process. We've changed our process. We originally were doing hydrogen and fertilizer, and then we were doing hydrogen and cement, and now we're doing SCM and cement, and then we're at a time where we've gone through 10 versions of the process. So anyway, maybe I'll stop there, and if there's any questions for Beth or me or anything about anything, please let us know.
Yeah, I'm going to squeeze in one last question here because I think it's interesting. And it's from Suraj, and he asked, do you or can you even model softer metrics, which may be harder to find, like the risk of switching to a new technology?
Yes.
Yeah, Cody changed a lot.
Yeah. You do that basically with a what's called a discount rate, and I think Beth has some good information on her intertechonomics videos about that. But basically, an investor is going to, there's always going to be risk to changing. So let's say I'm an oil refinery and I want to make hydrogen. So I could make hydrogen via steam methane reforming, which is the normal way to make hydrogen. And I know that works because I've built plants for 40 years that make hydrogen via that way. Or I could switch to water electrolysis, which has never been done at the electrochemical scale, and that has a lot of risk. So if I'm that company, I assign a price tag to that risk. And I say, I need a rate of return of 5% on my steam methane reforming plant. But if this water electrolysis plant can give me a rate of return of 20%, then I'm willing to take that risk. And you can basically model and say a good rule of thumb is, common industrial processes that are established need a rate of return of probably 8%, whereas a really new process probably needs a rate of return of 12% with project finance, or 20 or 30% with venture capital. So you can change your discount rate and compare your much higher discount rate to a much lower discount rate and assess that risk. And that's kind of the best way I know how to do it. I'm sure there's other ways.
Yeah, Beth, do you have a take?
No, you nailed it. Just another way of calculating that would be like using the internal rate of return, which is just another way of figuring out that number.
That's great. Well, I know we're over. Thanks everyone for staying a couple minutes. This is a really great topic, super important. So I appreciate both Beth and Cody being here. They're open to answer questions, as they've obviously made clear. And I want to highlight, as Beth said, we do have Chris Burke. He is a consultant for us, basically as Activate, and he is prepared to be working on a model for each of you. So the email address for him is in the digest. Please reach out and start getting going. So with that, I will wrap, and we'll see you all next week.
Thanks.
Hi, thanks everybody.
Thank you, Beth. It was great. And Cody.